Out there, beyond the edge of sunlight, beyond the faintest breath of the solar wind, a tiny human-made machine is still whispering across the abyss. 47 years after it was launched, Voyager 1 built, in an era when home computers didn't even exist, has just done something no one expected. For reasons no one at NASA can fully explain. The most distant object ever created by human hands altered its orientation, twisting to face the very system it had left behind. And then, it sent back data so strange, so impossible, that the scientific world froze. What could make a dying probe, billions of miles from home, turn in the dark? And what did it see out there in the silence between the stars? It all began in 1977, Voyager 1 and its twin. Voyager 2 were launched to ride a once-in-a-lifetime alignment of the outer planets. With less memory than a digital watch and the power of a refrigerator light bulb, these probes were never meant to survive half a century. Yet somehow they did. They delivered humanity's first close-up glimpses of Jupiter's storms, Saturn's rings, and the icy secrets of worlds we once believed were lifeless. And as their cameras shut down and their batteries aged, they just kept going beyond Pluto, beyond the Kuiper Belt, beyond every boundary we had ever drawn around our solar system. Voyager 1 became the first spacecraft to cross the heliopause, the invisible frontier where the solar wind dies and interstellar space begins. But when it crossed that line, something strange happened. The magnetic fields didn't shift the way they were supposed to. Plasma density spiked, yet the field's direction stayed the same, as if the probe hadn't left our solar system at all, but had entered a mirror of it. For years, scientists believed Voyager 1 had truly reached interstellar space, but new data told a different story. The probes for still-functioning instruments recorded subtle fluctuations in plasma, waves like echoes bouncing between unseen walls. The heliopause wasn't smooth. It was rippling, and the ripples were growing stronger. Then in 2018, Voyager 2 crossed the same boundary and detected the exact same magnetic alignment, the same density spikes, the same eerie lack of transition. Two spacecraft, 6 years apart, entering supposedly open space yet, both finding themselves in identical magnetic conditions. NASA's models couldn't explain it. The simplest conclusion that the probes hadn't truly escaped the sun's influence posed an even bigger question. What, then, is really out there? Was the heliosphere not a bubble, but a barrier? And if so, what was pressing back on the other side? In late 2024, Voyager 1's data stream changed. Its cosmic ray detector, operating decades past its expected lifespan, began registering short, rhythmic spikes, each exactly 11 minutes apart. At first, NASA dismissed this as system noise, radiation interference. But the spikes were perfectly timed, and their amplitude rose in exact correlation with the background plasma waves. Then came the transmission glitch. Voyager 1's antenna, which hadn't moved in over a decade, suddenly reoriented by half a degree. The maneuver was tiny, yet unmistakably deliberate triggering attitude thruster commands that had not been sent. The spacecraft had turned not toward the sun, but toward the source of the magnetic flux it had been detecting for months. When it did, the data changed again. The rhythmic spikes merged into a continuous tone, oscillating just below the threshold of human hearing. When decoded, the waveform revealed something NASA struggled to accept. A repeating harmonic ratio matching the fundamental frequencies of the hydrogen atom, the same constant, used to encode Voyager's golden record. The discovery split the scientific community. Some said it was coincidence, a plasma resonance trick. Others argued something far more profound had happened. Voyager 1 wasn't detecting a natural field. It was hearing its own transmission reflected back. The data patterns were identical to the probe's decades-old signal profiles, but inverted, as if bouncing off an unseen boundary. A reflective membrane surrounding the heliosphere, returning signals like an echo chamber at the edge of creation. For 3 weeks, the signal grew stronger and then suddenly vanished. When engineers at JPL analyzed the final frames, they found one last faint voltage fluctuation across the magnetometer. It wasn't random. It spelled out a binary sequence matching the time code of the golden record S first track, the sound of greetings from Earth. Voyager 1 hadn't just looked back. Something had looked back at it, Engineers worked around the clock. The data stream was faint, fragmented, nearly erased by cosmic noise, but a pattern remained. After filtering and comparing it with Voyager's historic transmissions, the resemblance was undeniable. The frequency envelope matched one of the probe's original calibration tones, but reversed and phase-shifted, as though reflected by something vast and structured. Using machine learning reconstruction, NASA converted the waveform into a 3D spectrogram. What appeared on the screen froze the room. The signal wasn't chaotic. It had symmetry 6 repeating spikes, forming a perfect lattice, a hexagonal resonance similar to crystalline structures seen in magnetized plasma chambers. Whatever Voyager encountered wasn't a random field. It was an organized boundary behaving like a membrane capable of shaping electromagnetic energy. Some called it the interstellar wall. Others simply called it the mirror. Soon, observatories worldwide detected the same reflected pingzar, exactly 19 hours after every Voyager 1 transmission. A mathematician at MIT noted that 19 hours matched the travel time for radio waves bouncing between Voyager 1 and an object 22 billion kilometers from Earth, just beyond the heliopause. It was a feedback loop. The more data Voyager sent, the stronger the return became. Then the impossible happened. Voyager 2, billions of kilometers away on a separate trajectory, began receiving the same mirrored signal. Two spacecraft, separated by the size of the solar system, receiving synchronized reflections. NASA attempted to decode it. Instead of language, a geometric map emerged, an expanding spiral intersected by radial lines. When plotted against star catalogs, the intersections matched interstellar clouds, forming a corridor pointing toward the constellation Ophiuchus. Each 72-hour cycle revealed more detail, as if layers were being added. The map wasn't pointing outward. It was folding inward, converging on the sun's position. It was mapping us. Converted to audio, the ratios formed a haunting hum at 115 Hz, the hydrogen tone encoded on the golden record. Then, on February 4, 2025, at 2:43 UTC, Voyager 1 performed another uncommanded maneuver, rotating 7 degrees to aim its antenna directly at the coordinates indicated by the geometric pattern. For 11 minutes, it transmitted a high-power burst into the darkness. Moments later, LIGO detected a gravitational ripple synchronized with Voyager's transmission. For the first time in history, a human-made machine had sent a signal into the interstellar abyss, and space-time itself responded. The gravitational echo wasn't random. It carried rhythm, symmetry, structure. Using 3D Fourier mapping, scientists reconstructed a toroidal latticin energy ring folding inward on itself. Embedded in its phase shifts were the coordinates of Voyager 1. For a moment, its frequency matched the golden record's bass tone. It was as if the universe had played our message back to us. Some whispered that Voyager had touched the event horizon of an artificial, constructed gravitational shell surrounding the solar system, not to trap us, but to contain something else. NASA locked down the data. Telemetry was encrypted. Publicly, the story was data corruption. Privately, it was fear. The final packets from Voyager contained compressed measurements far beyond what its systems should be able to produce. When expanded, the data revealed a repeating code 101101, one pulsing every 11 minutes. Just like the earlier signal, but this time, the source wasn't outside the heliopause. It was behind Voyager, inside the heliosphere, following it. Then a second signal appeared, neither from Earth nor from Voyager. For 19 minutes, it mirrored every Voyager transmission in real time, with perfect fidelity, as if two Voyagers existed, one human, one reflected coing each other across billions of kilometers. Then it went silent. Only a faint oscillation remained, not in radio, but in hydrogen's frequency, the universal constant we used on the golden record to represent intelligent life. NASA realized the unthinkable. Voyager hadn't reached the edge of the solar system. It had reached a mirror field of curvature in space-time, where electromagnetic radiation folds back upon itself. The boundary wasn't an exit, it was a reflection point. And hidden in the smallest harmonics of the gravitational echo was a timestamp. It pointed to the year 2031. One scientist said quietly, "It's not coming toward us. It's aligning with us." Voyager 1 is nearly silent now. Its one steady signal has degraded into static that rises every 11 minutes, the same rhythm it detected before turning back. Publicly, it's called a malfunction. But deep space monitors know the pattern continues. The pulses aren't coming from the probe. They're coming from the space around ITS. If something out there is still repeating our message, waiting for us to send another. So if this story made you wonder whether Voyager truly discovered something at the edge of the known universe, if you ever suspected our first message into the void was not lost, but heard Don't Look Away, subscribe to this channel, because the day Voyager's silence breaks, we may finally learn whether we were the first to reach out, or the last to realize we were never alone.